You know that saying that on average, we're only using about 10% of our brains? Well, it turns out the same applies also to how we use AI. According to recent studies, the average ChatGPT prompt is just 23 words. Explain this, fix my grammar, summarize this. Meanwhile, the latest frontier models like Claude Opus 4.5 and Gemini 3.5 Pro can handle up to 200,000 tokens per query, which is the length of an entire PhD thesis, with reasoning that rivals or even exceeds domain experts. And this isn't just theoretical. In Switzerland, AI was trained to successfully control 100 million degree plasma in a fusion reactor. JP Morgan built their own AI trader trained on billions of transactions, which outperforms humans and older algorithms. Microsoft Security Copilot utilized AI to review over 65 trillion threat signals a day, spotting attack paths untraceable for humans. So, whilst most of us are still using AI to tidy up our emails, the best firms are using it to reason across incredibly complex systems, research libraries, and global threat landscapes. I'm Manny Dashi, a cybersecurity advisor and AI architect. I've assessed and built production-grade AI systems across regulated industries such as banking, energy, and critical infrastructure, where the stakes are high and the margin for error is zero. In this video, I'll show you 3 core principles that separate generic chatbots from AI that delivers real business value, ROI, and a competitive advantage for personal and corporate endeavors. And I'll prove it across live domains. So why is there such a gap between what AI can do and what most people use it for? Because for most of us, AI still lives in a browser tab. You copy and paste something in, type explain this, get a response, and then you have to manually stitch everything together yourself. The AI has no idea about the actual environment and domain you live and work in. It doesn't know your internal obligations and processes. It has no idea about your infrastructure. It's reasoning in complete isolation. Thus, whilst big corporations and influencers continue to promote concepts like Agentic AI and autonomous copilots, very few are actually building the bridge between these models and the systems where work happens. So people walk away thinking AI is cool, but it's just a helper tool. Because the way they're using it is just a helper tool. They're trapped in a box. So the real question isn't whether AI is smart enough, it's whether we're giving it the chance to be useful. Now the big question, how do we unlock what AI can really do for us? It comes down to 3 pillars: allowing AI to see, act, and know. Think of today's AI as an incredibly smart and knowledgeable consultant. They generally know your domain, they can reason deeply, and also deliver sharp insights. But even the best consultant can only help you if they're given access to your data, the right tools, and truly understand your environment. Without that, they will always be stuck giving generic advice. In my work designing AI systems and conducting cybersecurity assessments alongside some incredible solution and security architects, I've seen the following firsthand. And these are the exact same core principles used to power the latest Microsoft, modern RAG, and agentic frameworks. Let me walk you through what they mean and how they work in practice. First, connect the data and break the silos. As I alluded to, when AI can't see the full picture, it can only ever give you shallow outputs. The unlock involves bridging that gap, giving AI secure access to the necessary areas of your environment, such as your files, your systems, and your workflows, so that it can reason across the bigger picture. And we're already seeing this play out. Microsoft Copilot utilized Graph API to connect and access your firm's Microsoft ecosystem. RAG systems index your documents for almost instant retrieval. And with new protocols like MCP, you can now integrate AI into almost any enterprise application. Jira, Salesforce, Confluence, you name it. Second, give it tools. AI that can see but can't act, that's like a consultant who's not allowed to touch a keyboard. When you enable AI to use tools like APIs, function calls, and control loops, the model can now decide, I need to query this system, run this calculation, call this API. For example, agentic systems can pull data from CRMs, draft responses, and execute changes, with human in the loop at key checkpoints. AI now stops advising and starts delivering. Third, ground it in your world. And this is the one that most people miss. AI doesn't know, for example, that when you say Q4, you mean your fiscal year and not your calendar year. It doesn't know what a critical finding is in the context of your company. The fix? Give AI a knowledge base, your organization's definitions, rules, and context. And this is different from giving it just data. Data is the raw information like your spreadsheets, documents, and legal acts. A knowledge base tells AI how to interpret that data. For example, in cybersecurity, we would connect our governance policies, standards, baselines, etc., which define the organization's risk management, internal requirements, remediation SLAs, and more. You can also shape AI behavior, as you probably know, through system prompts, telling it your preferred tone, format, and priorities. For example, telling it you're a compliance analyst, use formal language, and always cite article numbers. Now it starts to think like a member of your team, not a generic chatbot. Now let's see these principles through key domains, including finance, legal, and cybersecurity, and see these patterns in action with real systems and live demos. Okay, so let's start with finance. If you've ever worked in finance-related roles like FP&A, you know this pain. You have to constantly manage and navigate through dozens of interconnected Excel workbooks. Revenue models feeding cost models linked to supplier pricing, assumptions feeding forecasts, which then feeds a slide deck to the leadership team. And then someone asks, why did margin drop this quarter? Now you have to go back and manually trace through cell references across several Excel sheets, spending even further hours of manual work, which is error-prone and tedious. And if you try to paste some spreadsheets into ChatGPT, if your business even allows it, it can't see the other files. It doesn't understand the links, and the AI is siloed. This is exactly where the see, act, and know principles can apply. C. Give AI access to all the required folders stored in the financial models, not just some sheets in isolation. Act. Equip it with the right tools to read sheets, formulas, trace references, and follow dependencies. Know. Ground it in your actual data, your naming conventions, your structure, and reporting guidelines. There are many ways to implement this, but let me walk you through one way which I designed. Okay, so through this design, as you can see, for the presentation layer of the AI responses, I've chosen to use Excel and Power BI through embedded AI panels, which they support. And I've also aimed to use Teams as the primary front-end chat interface for users. Teams has to first go through the bot service in order to be able to talk to the LLM within the backend and also render the responses, whereas Excel and Power BI can go direct to the app gateway. And the primary role of the app gateway is to verify users through Entra ID validation. It also has other key security points in place, such as integration through the WAF and rate limiting as well. So once the right users have been verified and authorized to proceed, their LLM query through any of these three channels will then pass to the function app, which is the orchestrator. The function app, as you can see in the description box, has several key roles. The first one is also primarily to link to the key data sources. So for example, it links to SAP ERP, and that is what we're using for grounding, because SAP ERP is what a lot of enterprises use. And it grounds it in the financial world by translating and allowing AI to interpret the data. For example, to understand what the geocodes are, financial policies, and your specific organization definitions. It also talks to the Excel MCP server. This I'm hosting on a function app within this design. And the MCP server allows the LM with the right tools, so this is ACT, in order to effectively and properly understand the Excel workbooks. It then connects to your organization's SharePoint through Enter ID tokens, which are obtained through the user actually using the tool within the front ends. So this is OBO exchange and delegated auth in order to maintain the principle of least privilege and ensure that the function app can only access the files and folders and environments that the actual end user can within SAP as well, based on the assumption that it is using SSO and Enter as well, and SharePoint. I've decided to use a Redis cache as well to improve speed of similar queries, which would store the MCP cache as well as the semantic cache of popular queries. And I've opted to use a self-hosted LLM in this case, not only for cost savings, but also for ease of use and as well as greater scalability, because you no longer have to pay for tokens, but just for the VM hosting costs that Azure defines. And I've chosen to limit access to a private endpoint to ensure that no LLM queries go over the public internet in this case. Okay, so for this live finance demonstration, I am using the Claude desktop app on my personal PC. So hence the change of scenery behind me, which is the living room. As you can see, we are running a live local Excel MCP server. So although this is obviously different to the solution design, which we just walked through, the exact same principles apply. And because this is so easy to set up locally, I will include the link to the MCP server in GitHub in the description so that you can also test out yourselves if you'd like. For the data, we'll be using 3 Excel sheets containing dummy data for a sample organization. So in this case, we have the Q4 actuals and the Q4 budget for various GL codes, and that represents the raw data. And we also have a chart of accounts, which allows AI to understand how to interpret the data in this case and grounds it in our world by understanding the specific account names, category, and approval policies, tying back to those GL codes. And let's see this in action with our first query. So in this case, we're asking the LLM, which is Opus 4.5, to use the Excel MCP server, so the tool, to effectively understand those 3 files within our environment, so directly access them and not operate as a silo, and perform the following key tasks. So compare the Q4 actuals table to the budget, so those 2 different Excel sheets together. Identify which GL codes are over budget and by how much. And for those codes, identify the department that owns them. So we're grounding the raw data responses into our world. And as you can see, another key benefit of this approach is that it allows for auditability and traceability through understanding the key steps the LLM performs to reach its response, so that we can always trace it and understand its key operations, as opposed to the generic web chatbots, which are black boxes. Now, comparing the results, we can see that the AI has effectively synthesized the Q4 budget and actuals tables, which are in fact separate originally, but it's combined them both successfully, depicting the total budget compared to the actuals, the specific GL codes over budget, and the departments that own them. So I'll quickly show you correctness and accuracy. So I have verified this. So for example, we can see that the digital advertising GL code is over by 15,000. And if we look at the row, digital advertising budget is 30,000 and the actual is 45,000. Thereby, the AI has effectively answered all our 3 tasks, utilizing the Excel MCP server to understand the actual data and also synthesize it across various sheets, grounding it back to our context here in the key takeaway, depicting that marketing is the biggest concern, accounting for 28,000 of a 32,000 total overrun. Now I will show you this in action through one more query, and this query is a bit more complicated than the first one. So now we're asking to create a new sheet within the Q4 Actuals Excel workbook to show a consolidated variance report combining all 3 files with a variance column, percentage of over and under budget, and also highlighting of over budget items in red. So now we're going to explore its ability to also edit Excel sheets and not only read them effectively by creating new columns, understanding percentages, and also formatting through highlighting. So as you can see, the LLM is currently using the Excel MCP server to perform these operations. We have the paper trail of its key tool usage to understand how and why it is performing these steps. And this does take a bit of time, so about 15 seconds. So let me cut to the response once it's complete. Okay, so the LLM has completed its response. And as you can see, another key benefit is that because we're giving it access to the necessary files within our environment, it allows it to verify the final results by directly reading the new sheet, in this case, to verify that the formulas and the cell references, for example, are correct, thereby further reducing the risk of incorrect responses and hallucination. So it has created the new variance report sheet within the Q4 Actuals workbook with the following. Let me show you that now. Okay, so this is the new table which it has created, perfectly answering our requests. So as you can see, it has highlighted the GL codes in red that were over budget. Also creating new columns depicting the total budget for the Q4 across all GL codes, the actuals, the variance dollar amount, so the over budget, the overspending, as well as the percentage of the variance. And another key benefit of this is that it has used Excel formulas and not static values for the actual totals across all columns, thereby allowing for further testing and confirmation of the results as opposed to a hard-coded and static value which generic chatbots can output. So this thereby illustrates the advantages of allowing AI to act, see, and know within the finance domain, which I've shown through connecting AI to an Excel MCP server, granting it the tools to effectively access our data directly, as well as interpret how to analyze it by grounding it in our context, which in this case was the chart of accounts. Let's move to a use case within legal and compliance, and this is where I'll show you my flagship project. If you work in any regulated industry, like banking, healthcare, and pharmaceuticals, you know just how complex and difficult it can be to navigate through compliance requirements and reach a legal answer. Regulatory frameworks are hierarchical. Laws reference ordinances, ordinances reference circulars, and circulars can reference guidance documents. Someone asks a seemingly simple question like, what rule applies to our situation? And you're down a rabbit hole for hours. The problem with asking generic AI legal queries? Hallucination. Sounds right isn't good enough when you're defending a decision to auditors. You need citations and you need real sources you can verify. So how do you solve this? Well, that's what I've attempted to do through my flagship project, which is Swiss Compliance AI. Let me walk you through the conceptual solution design on the right, depicting my website as well as the backends. Okay, so users first interact with the front end via a public website, which in this case is swisscompliance.ai, and this is actually up and running, so I really encourage you to check it out yourselves. The web requests first hit CloudFront, which is AWS's CDN, and also our edge security. So it's doing WAF filtering, DDoS protection through AWS Shield, and also caching the site at various locations for greater efficiency. Valid requests then get forwarded into our private subnet to an ECS Fargate specifically. And this hosts the front end, manages user sessions, and also orchestrates the whole retrieval pipeline. I chose it over an EC2 instance, for example, because it is serverless. There's no need to patch it, such as you would need to for a VM. And also it allows for auto scaling. So when a user asks a Swiss legal query, Fargate will then call our Lambda function, which is our GraphRag engine. And in reality, you could combine these two functions just into the one ECS Fargate. However, I chose to decouple it in this case, just to allow for clarity in terms of roles and separation of duties. So this Lambda is doing the heavy lifting, federated retrieval and cross-encoder re-ranking. So the Lambda queries two data sources, as I alluded to earlier, in parallel. We're using AWS Neptune as our graph database, and that stores the actual legal hierarchy, entities, and relationships. because, as you know, especially for the legal domain, the environments that we live and work in aren't flat and can't be represented just in documents. Thus, to allow AI to fully see the ecosystem and navigate within the environment that we live in, we also need it to understand relationships, which is what we do conscientiously. Thus, to enable that, we use a knowledge graph, which has the legal entities, for example, which could be laws or corporations, as well as their relationships, which allows us to depict the legal hierarchy and links between different laws. So, for example, how the banking ordinance in the Swiss context implements and provides more detail on the Banking Act. For example, the Anti-Money Laundering Act has parallel scope to the Banking Act, are two forms of relationships which a GraphDB allows us to define for our AI to understand too. And for the VectorDB, we're using AWS OpenSearch, and that does hold the actual document embeddings of the legal laws. So, for example, the Banking Act, as I alluded to earlier, and also FINMA Circular 2023-1 on operational risk management is another key example, allowing for semantic similarity search of those law articles and contents. Okay, so when you combine those two, you allow for graph traversal plus semantic similarity, and that allows for GraphRag. We then re-rank the results using a cross-encoder to surface the most relevant chunks. Chunks is a technical term, but for layman's purposes, think the articles that are returned. So, for example, when you ask, what are the capital liquidity requirements for my firm? The re-ranker would get rid of those chunks that aren't really relevant to that query so that the LLM isn't confused and gives you a wrong answer. Those final re-ranked chunks get passed to Bedrock in this case, so we're accessing the LLM via an API as opposed to locally hosted in a previous example. And I've used Claude 3.5 Sonnet as an example LLM in this context, which is great, which then generates the final answers with citations, noting the source data that's been pulled from the GraphRag. And also, if you need to pull precedent documents or contract templates specific to your organization, you can also do that through the Lambda using OAuth credentials from Secrets Manager, so never hard-coding them, and making an outbound call to your NetDocs environment, which is a legal document management system that is very popular for large enterprises. That traffic goes out via that gateway, so only allowing egress and no ingress traffic. So this secure architecture results in legal answers that are traceable, verifiable, and truly based on the real complex regulatory ecosystem, thereby addressing the extreme risk of AI hallucination, especially within a legal domain. Okay, and for this legal demo, let's use my prod app, Sys Compliance AI. So we're at the landing page here, and although this isn't available publicly, because I'm locally hosting this for this demonstration, I can access the chat feature. And this demonstration will show you the benefits specifically of GraphRag, which although it is being applied to in this case for the Swiss financial regulatory context, it applies to any legal domain or jurisdiction. So let me show you the benefits of it with two queries. And the first one which we'll be using is asking the Swiss Compliance AI to explain to us the designation criteria for systemically important banks. And as you can see, this app has a thinking panel, which also provides you that traceability and auditability into how it's retrieving the appropriate legal articles. So in this case, we can see that it is utilizing graph relationships, which I alluded to earlier, which allows AI to actually understand the environment which you operate in, which is especially pertinent to the legal domain, which flat files and vector DBs in isolation cannot adequately depict. So for example, we can see here that already we're seeing links between different articles. So Article 8 of the Banking Act implements Article 62 of the Banking Ordinance, and also cross levels, the legal hierarchy. So the Banking Act is linked to the Banking Ordinance, which is a different level of the legal hierarchy, as well as FINMA circulars through FINMA Circular 2023-1, and then RN 61 to 68 is the actual reference. Okay, so let's look at the response. And I've told it, in this case, to act as a senior legal advisor, so hence why it's saying in my experience. advising financial institutions. And then it goes into the actual references and legal articles it is used to answer this question, just as a expert in compliance would. And another key feature of my app is that it has a sources panel, which allows you to see the actual articles verbatim that the AI is referencing to further reduce the risk of hallucination by providing you that traceability into what it's actually citing. Okay, so it's using these to explain one, the designation of banks as systemically important, which directly ties to our question here. So, for example, if they provide functions that are deemed systemically important and vital to the Swiss economy in this case, it then talks about practical applications through major institutions like UBS, where it then links to a different article, so Article 9 of the Banking Act, which states that systemically important banks shall meet special requirements, which it talks about here. And another key feature is that within assistant prompts, I really told it to hallucinate as little as possible and paraphrase as little as possible to maintain that legal wording, which is especially important to avoid confusion or ambiguity in responses. And lastly, it has also referenced the FINMAIA legal document as well, where it uses that to determine how the SNB further regulates the details, emphasizing the need to protect the finance system stability as defined in Article 23 of FINMAIA, as well as the next steps. So this shows how you can utilize GraphRag, especially in the legal domain, to allow AI to effectively understand the relationships between different docs and then provide a real and correct answer with as little hallucination and drift as possible. So that is for an easy-ish query. Now let's see for a hard one, which I entered earlier. And now we're asking it to explain capital adequacy requirements across all three levels of Swiss regulation. So acts, the Banking Act, ordinances, and FINMA circulars. So as you can see, this is quite a long answer, and I'm happy for you to pause the video to read it yourselves. But as you can see, it is effectively traversing and navigating through the different levels of Swiss hierarchy, also interpreting and synthesizing those in the answer. So, for example, it says that the banking ordinance provides further detailed guidance on how capital adequacy requirements defined in the Act, so the higher level, are to be implemented. And then you can utilize the sources panel to really see what article it's actually referencing and how, to determine yourselves if there's any hallucination, and to ensure that you also understands where it's coming from so that it isn't a black box as opposed to generic chatbots. Finally, my home turf, IT and cybersecurity. Most large corporations utilize a combination of different vulnerability scanners. Nessus, Qualys, and Tenable are your primary infrastructure scanners. Snyk and Dependabot are your SCA tools, and maybe Wiz or Prisma is utilized for CSPM. They all do their job, but that's the problem. You can easily end up with over 2,000 findings across 3 different dashboards comprising of critical, high, and medium vulns based on CVSS scores that know nothing about your environment. For example, a medium severity vulnerability sounds manageable, but what if it's on an internet-facing server with an over-permissioned IAM role that can access your customer DB? That's not medium, that's a critical attack path and risk. But most scanners just use individual findings, and they don't really understand your environment. So one AI solution is to model your infrastructure as a graph for AI to truly understand your network and environment. Nodes are assets, so your EC2 instances, your PASs, your IAM roles, whereas the edges are the relationships, so the network paths and permissions. Feed that into an LLM with MITRE attack knowledge, and you can now ask, what are the highest risk paths to our critical infrastructure and systems? And the AI reasons over the graph, finds vulnerable combinations, and prioritizes real attack paths, not individual vulnerabilities. The data connected is the cloud APIs, scanners, and IAM all feeding the one graph. The tools equipped is the graph queries and path analysis, and we ground it in our context by providing our firm's governance documents, risk appetite, and any relevant frameworks. Let me show you a simplified conceptual solution design on one way that this could be implemented. So this is a design I created for an AI-powered attack path analysis tool hosted on Azure. Security teams could use something like this to ask queries like, what are my most critical attack paths for tier 1 systems? And the backend system traverses an infrastructure graph enriched with vulnerability data, MITRE ATT&CK and Atlas mappings for threat modeling, and your governance context. So instead of traditional vuln reports showing 500 isolated CVEs, you get specific, prioritized, and contextual attack chains with proper remediation guidance. So security analysts for this kind of system would access it via HTTPS with Entra ID authentication. So it leverages your existing firm's Entra ID and SSO setup. Requests would first hit the container app, which interprets the natural language queries, plans a graph traversal, and correlates findings with MITRE ATT&CK and Atlas frameworks. For natural language understanding and reasoning, we're going to be calling Azure OpenAI service in this implementation through a private endpoint. Data sovereignty is built in and content filtering would be enabled. The data source for this AI system is a CosmoDB, storing our cloud network topology and environment config, assets, vulns, threat attacks and techniques, as well as our internal cloud governance docs, frameworks, and risk appetite. So in this case, the raw data would be everything besides the cloud governance, which in our case allows AI to ground its responses in our world. Feeding that graph is the function app. In this case, it's pulling data from several sources depicted in order to allow the LLM to truly understand the context of risks within our environment through the Azure resource graph depicting the network topology, their exploitability, and true risk likelihood and impact. All credentials for the outbound API calls are stored within Key Vault, so nothing is hard-coded and all keys are rotatable and auditable. Okay, and lastly for this IT demo, I've chosen to do it via a really simple React front-end in this case, talking to GPT-4o Mini, so that's our LLM within the backend, and the network topology we're assessing is this one on the right here. So it depicts a really simple network where customers or users would interact with the backend via a WAF, which talks to an app gateway and then one of these two web servers and an API server to then query an Azure SQL DB. So for this demonstration, it'd be storing customer PII and financial data. So for example, their balance, as well as their address, email, phone number, etc. And users for legitimate use cases will need to query it, for example, when looking to change their email address or obtain their balance. So GET requests as an example. Okay, and we've just been alerted that there's two vulnerabilities existing within this system. So let's run our first query. And this is asking the AI to determine the critical attack paths to the DB, not only, however, identifying those in isolation like what traditional vuln scanners do, but showing contextual risk analysis concerning our system and where they are in that. So it is just completed. And as we can see, the diagram is updated to show the critical attack paths by risk criticality. So we can see already that from the internet to the jump box in this case, which for this use case could be set up by the infrastructure team for remote administration, has a high criticality attack flow, and the Azure SQL DB is under a critical vulnerability, which would need to be patched ASAP. Okay, now looking at the AI response for this demonstration, I have really asked it in the system prompt to link back to all 5 risk source in this case. So firstly, we can see already that it's linking back to ServiceNow for our CMDB and asset management, informing us already of who owns the vulnerable systems. So we can see the IT infrastructure team owns the jump box. The web server is owned by the web platform team, so there's also a vulnerability in the web servers. And the Azure SQL DB is owned by the data platform team under finance in this case. Okay, so it has identified 2 vulnerabilities in 2 systems. So the first one is CVE-2024-1234, and that's a WordPress related vulnerability with a CVSS score of 5.4. And that actually is a real risk, so I'll show you that here. It was identified last year at the time of this recording, and it is connected to a CSS attack via WordPress. Now, it is now incorporating our internal risk appetite and frameworks by judging the risk score based off likelihood and impact, which is what we do in our enterprise and a lot of other large enterprises do as well, where it is identified the total risk level or risk score is 8 out of 8, which is critical and the max. Thereby, according to our internal risk remediation SLAs, it needs to be remediated within 1 day or 24 hours. The likelihood is max because this jump box actually is publicly exposed with no MFA, and the WordPress exploit therefore is much easier for hackers to gain access to. And the impact is also max because it is using an owner RBAC permission, which allows for full Azure access to the Azure SQL DB if the hacker ever gained access to it. The web servers also have a vulnerability, and now you can see contextual risk analysis in play, because although this vulnerability is rated higher by CVSS, and it's actually max of 10, so this is CVE-2024-3094, that's this one, which allows for exploitation of a specific Linux library to allow for RCE, so remote code execution. Now, although this vuln is high in isolation, the likelihood and impact is lower because the web servers are still behind a WAF, which would block traditional exploit payloads, and they require MFA. And they can also reach the customer DB, but their contributor role limits the blast radius if compromised. So therefore showing contextual risk analysis at play because the total risk is actually a medium, therefore the SLA is only within a month, as opposed to the first one where the vuln is lower, but the contextual risk is higher. And that's really what businesses need, not isolated vulns that are almost meaningless, but real contextual risk analysis, which AI can perform for you. Okay, then walks you through why it's higher, because of the exposure, authentication, privilege level, and compensating controls, which the web servers have and a jump box doesn't. And then the attack chain. So let me run through one more query just to further understand how hackers could pivot through our network to reach the DB. And in this case, the AI will use MITRE to determine the threat modeling attacks and techniques that hackers could utilize so that we better understand how this risk could be exploited and how to best fix it. Okay, so it's just finished. It's again linking back to our assets in ServiceNow and our internal risk score that we define. So grounding the response in our world. And we can see here the attack chain. So SSRF plus header injection will allow them to steal the credentials of this jump host, and then a data breach of the Azure SQL DB. And then it utilizes MITRE for threat modeling, as I talked about earlier, with real techniques. So, for example, MITRE T1595 is the real technique used for active scanning during the reconnaissance phase. So it's linking back to that to really elucidate and walk through how hackers could fully exploit this vulnerability in its entirety. And then states how hackers could exploit the XSS within the WordPress, in this case, to trigger SSRF, thereby granting access to the jump box without knowing the credentials. And then once the hackers have access to it, they could then exfiltrate the customer PII and financial data within Azure SQLDB due to the lack of RBAC for the jump box, and also a bulk export of customs table, for example, to their own blob storage within their environment. And the critical insight is that they never hacked the jump box. They exploited a web tier flaw to trick the VM into leaking its own managed identity via IMDS. And we also have a remediation priority. So not only showing us the risk, how it can be exploited and why it is a critical in this case, but also how to fix it through enforcing metadata security protocol, least privilege, VM attestation, and patching the WordPress to fix that CVE. Cool. So as a whole, this thereby shows how you can unlock AI specifically within the IT domain, taking the next step from just isolated vulnerabilities to allowing AI to fully understand your network topology, assets, vulnerabilities through, for example, Tenable, threat modeling attacks and techniques through MITRE ATT&CK and Atlas for AI, and your internal risk management frameworks and risk appetite so that it can ground the risk scores in your world, thereby delivering you full contextual risks based on your environment and how to fix them. So, 3 domains: finance, legal, and cybersecurity. Different data, different clouds, and different problems. But the same 3 pillars made AI useful in every single case. Connect the data, give it tools, and ground it in your world. That's the pattern, and it transfers. And the ROI is substantial. Across these 3 use cases, we're looking at between a 92 to 98% cost savings compared to enterprise alternatives. That's anywhere from $98,000 to $446,000 a year per use case back to your budget. And that's not counting the time savings. Questions that used to take hours now take seconds. Analysis that required third-party consultants can now happen in-house. And cost is only part of the story. You also ensure data sovereignty. Your LLM calls, your documents, your infrastructure data, it all stays within your environment and not routed through a vendor's cloud, but yours. And in my use case demonstrations, also within your region. You also have full customization. You control the prompts, the tools, and the knowledge base. You're not waiting for a vendor roadmap or locked into what they decide to ship. And lastly, transparent reasoning. Every AI answer is traceable to a source, a cell reference, an article number, an asset ID. No more black boxes. Please check out my website, Swiss Compliance AI, to learn more about how to use AI specifically in the legal domain and harness GraphRag. And if you're working in similar areas, especially in the UK and Europe regarding AI, cybersecurity, and critical infrastructure, please reach out as I'd love to exchange ideas. I'm Manny Dashi. Thank you so much for watching, and I'll see you in the next one.